Okay, friends, this next bit about pie charts, I think I'm going to do on the chalkboard. It's going to involve proportions again, like the last one did, because anytime you use percentages, it ends up being a proportion. So the last one we did using Google, this one we'll do on the chalkboard. That way you can kind of find whichever one you like the best. So in this little thing here, you're looking at a pie chart involving percentages of colors in M&Ms. This is actually a fun project I used to do in my stat classes, where I'd bring a bunch of bags of M&Ms in and give one to each kiddo, and they'd all crack them open and they'd test to see if the colors in their bag matched the colors in that pie chart. So if you look at that pie chart, you got 13.1 red, 12.4 brown, 20.5 orange, and so forth and so on. And those are the pie chart colors they tell you are supposed to be in bags of M&Ms from the Cleveland factory, which I just find it hilarious that Mars actually keeps track of this data. As it turns out, they're often wrong, but whatever. It's a fun math problem to look at. So it says pick your favorite M&M color out of whatever the 6 colors you see there are. If you have a bag containing 55 M&Ms, which is usually like one of the little bags we used to use in class, about how many would you expect to find of your color? Okay, so the thing about a pie chart, as you saw, was it shows percentages, percent. But the problem is, this one is not percent, it's per 55. So the question is, how many per 55 would you assume if they tell you something percent? So you see how it's 55 to 100? The percentages they give you, that little symbol, percent. Let's pick one. Pick one for me. You can't pick one for me. You're watching the video. All right, what's the first color I see? Blue. I see blue up there in my office. Blue, 20.7%. So it's 20.7% is how many over 55? Is how many over 55. So all you got to do now is solve this proportion using whatever method that you want to do. Now, if you had me in previous math classes, we developed percentage and proportional methods. Method 1, Method 2, Method 2A, I think. So the way a lot of students like to solve these is they do the diagonals multiplied and set them equal to each other. So in this case, you would do 55 times 20.7, and then you would divide by the 100. And that's going to tell you about how many blue ones you should see. So I'm going to jump down here into Google and do that. And I get a question mark of about 11.385, which is about 11 blue M&Ms. Which makes sense because 20% is about 1/5. So about 1/5 of the 55 should be blue. Okay, so that's one of the methods that we've established over the past of solving proportions. Okay, for this one, we've got a huge bag of M&Ms from this plant, and we have 47 yellow ones. How many M&Ms are likely to be in the bag? So yellow, remember, yellow tells us there should be 13.5%. Percent. Now, I know some of you write these as 0.135 or some other version of that, and that's fine. I just like to hammer home the point that 13.5% means 13.5 per 100. Per 100. But they're telling you you've got 47 yellow ones. So 47 out of how many? Now, we can get close to this answer, I think, with some approximation. Let's approximate. 13.5, how many times do you have to multiply that by to get 47? It's about 3. It's about 3. So that means you have to multiply this by about 3 to get to 300. So if all you need to do is to get into the ballpark, just figure this times 3 gets you to about here. That means this should be about 300. And a lot of times, that's good enough. If you need to get more precise, you can do the exact, even though this is a different proportion than the last one was, you can do it the same way. That times that, divided by that. And that's going to tell you how many M&Ms are in the bag. Let's find out. I get about 350. Which is pretty close to my estimate. We guessed about 300. It's really about 350. So it all depends on how much precision you need. But proportionally, it's all the same. 47 is to what as 13.5 is to 100. Boom, there you go. Let's do one more. All right, this one I'm going to move back to the computer because I think it's actually going to be easier to do this not with a chalkboard. Check out number 30. If you want to divide a pile of M&Ms up into 3 piles, each pile consisting of 2 colors, how could you split them up so that the piles were as equal as possible in size? Okay, so let's look back at this pie chart up here. This is the percentage allocation that Mars tells us should be in a bag of M&Ms. Now, we don't know how many M&Ms are actually in this bag, and it doesn't matter. We're going to assume that this color combination is what is actually in the bag. So, for every 100, 20.7 are going to be blue, 20.5 are orange, and so forth, and so on, and so forth, and so on. We want to take all 100 of these candies, or 200, or 300, or whatever they are, and we want to break this pie chart, which has actually got 6 not quite equal pieces, into 3 pieces that are as close to equal as possible. Now, if you think about a pie chart that's broken into 3 pieces that are as equal as possible, what percent are they all going to be broken into? Think about that for a second. What percent are each of those slices? And it doesn't take you very long that if you break them up into 3 equal pieces, they're each a third, which is 33.3% each. 33.3, 33.3. There you go. So what we need to do is we need to combine these percentages 2 at a time to get as close as we possibly can to 33.3 each. Now, if you look at the actual percentages of the Cleveland M&Ms here, you know pretty quickly what you shouldn't do. You shouldn't add 20.7 and 20.5 and put those in a pile, because that's the 2 biggest percentages, right? You don't want to add those together because then you don't have enough in the other percentages. Likewise, you probably don't want to add the 2 smallest percentages. You probably want to combine the large one with one of the small ones. So let's try something here. I want to give it a shot. Let's take 20.7 and combine it with 12.4. What does that end up getting us? That gets us 33.1%. That is not bad. 33.1 if we do brown and blue. Now I'm going to put orange with yellow, and that's going to get me 34 even. And if I put green with red, that's going to get me 32.9. That's pretty darn good. Can you do better? It's just an exercise to have you kind of refamiliarize yourself with percentages. Okay? And I think that takes us into our next video where we'll learn how to make our own pie chart. Let's have some fun.